Okay, so today we're doing limiting reactant and percent yield notes. The first thing is you need to know the definition of a limiting reactant. A reactant that is totally consumed during a chemical reaction. It limits the extent of the reaction and determines the amount of product produced. We'll talk about that in a minute. Excess reactant is a reactant that remains after a chemical reaction stops. The percent yield is the ratio of the actual yield versus the theoretical yield. And there's the equation for that. So let's just try an example. I have example number 1. We have how many grilled cheese sandwiches can I make if I have 42 slices of cheese and 32 slices of bread? Which ingredient was limiting and which one was in excess? So if we begin with the 42 slices of cheese, so the given is 42 slices of cheese, we're trying to find how many grilled cheese sandwiches. The conversion factor is that it's 3 slices of cheese are equal to 1 grilled cheese sandwich. We get that from this relationship right here. Then, for the solution, we can begin with 42 slices of cheese, 1 grilled cheese sandwich over 3 slices of cheese, and that would give us 14 grilled cheese sandwiches. Okay, now if we had 32 slices of bread, we'll do this over here. If the given is 32 bread, we're trying to find sandwiches. The conversion factor is for every 2 bread equals 1 sandwich. Okay? The solution would be, if we have 32 bread, there's 2 bread for every 1 sandwich, and that would equal 16 sandwiches. Okay, so what this is telling us is that the 42 slices of cheese can produce 14 grilled cheese sandwiches. The 32 bread can produce 16 sandwiches. So it's the cheese that is limiting us from having more sandwiches. Okay? 42 slices of cheese can only make 14 sandwiches, whereas if we had 32 slices of bread, we could have a total of 16 with cheese. So the limiting reactant is equal to the cheese, and what we have in excess, which is too much of, would be the bread. We would have some left over. Okay, now, I burned some grilled cheeses and I was only able to make 10 edible grilled cheeses. What is my percent yield? If the equation is actual versus theoretical, in this case we have 10 actual sandwiches over the 14 which are theoretical. The theoretical is always the limiting reactant. Always. Times 100. That ends up to be 71.4% yield. Okay, let's try example number 2. We have an actual formula. It says, what mass of phosphorus pentachloride can be produced by reacting 16 grams of chlorine and 23 grams of phosphorus? So we'll set this up as 2 separate problems. The first one, we have the given is 16 grams of chlorine, Cl2. We're trying to find grams of phosphorus pentachloride. The conversion factors would start off with grams of chlorine. We're going to convert it to moles of chlorine. And the mass here is 71. Okay? Next, we're going to go from mole of chlorine to moles of phosphorus pentachloride. If you look at this relationship right here, you would see that the relationship between the chlorine and the phosphorus pentachloride is a 10:4 ratio. Then we're going to convert the phosphorus pentachloride moles, and we want them in grams of phosphorus pentachloride. We would use the triangle to find the molar mass here, and it's 208 for every 1 mole. Then we can plug it into the equation. We have 16 grams of Cl2. For every 1 mole of Cl2, it's 71 grams of Cl2. For every 4 moles of PCl5, we have 10 moles of Cl2, and for every 208 grams of phosphorus pentachloride, we have 1 mole of PCl5. Your answer would be 18.8 grams of phosphorus pentachloride. Okay, now we have to take the 23 grams of phosphorus, so the given is 23 grams of phosphorus. We're trying to find grams of phosphorus pentachloride. The conversion factor is from grams of phosphorus to moles of phosphorus, which would be about 124 for every 1 mole. Now we need to go from phosphorus to pentachloride using the relationship here. We have 1, by the way, it's P4 here. We have 1 phosphorus for every 4 phosphorus pentachloride. The next, and these are moles. Now we'll go from moles of phosphorus pentachloride to grams of phosphorus pentachloride, and the relationship there using the triangle with molar mass is 208. Okay? Next, we will begin with what we have for the solution, 23 grams of phosphorus. For every, I have to stop.